Hello there, and welcome back to the Science Sleepy Minds. Tonight, you're standing ankle deep in the dust of stars. Not metaphorically, no, literally. The ground under your bare feet is chilled basalt, but scattered across it are fragments older than Earth, the cooled bones of stars that lived and died long before your sun had its first tantrum. Overhead, the sky's thick with stars, yes, but it's what's missing that catches your attention. Right there, near the constellation Sagittarius, a patch of black that swallows starlight like it's thirsty. You're about to walk toward it. Yes, toward the one thing in the cosmos that isn't really a thing. The closest approximation the universe has to nothing. And you probably won't survive this. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Let me know in the comments where you're tuning in from and what time it is. Midnight in Mumbai? 3 a.m. in Toledo? Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start walking. There's no trail, no map, and certainly no tour guide, unless you count the goosebumps prickling your arms as cosmic breadcrumbs. The air smells like ozone and cold metal. In the distance, you see a shimmer in the atmosphere, like heat rising from asphalt, but it's night and there's no sun here. That shimmer is something else. A distortion in space-time, and it's growing. Under your feet, a massive star has just died. Not in a gentle, poetic dimming, but in a rage of physics, supernova. One of the most violent deaths in the cosmos. The kind of explosion that can outshine an entire galaxy for a few days before disappearing, like a diva exiting the stage. But it doesn't end there. You keep moving, crunching over gravel that probably once circled that star as a planet or moon. A few million years ago, something inside that star gave up. Its nuclear fusion engine shut down. Without that constant outward pressure, gravity took over like a vulture, pulling everything inward. The star's core collapsed, first into a dense neutron star. Then, if the mass was just right, above about 3 solar masses, it kept collapsing beyond even neutron resistance straight into a black hole. What does that even mean, though? Imagine a sphere with the mass of 3 suns, packed into something the size of a city. Not small by earthly standards, but ridiculously tight by cosmic ones. You try to picture it, but your brain does that thing where it throws up a 404 image not found screen. This isn't just dense, it's beyond dense. It's the death of structure as you know it. Historians still argue whether ancient civilizations ever truly grasped the scale of such events. Some point to old myths of sky holes, star eaters, or serpent loops as metaphorical nods to them. Others insist those stories were just about eclipses and overactive imaginations. But you wonder. In the dim sky, you notice something. An oddly bright ring hovering around a dark circle. That's an accretion disk. As matter spirals into the black hole, it heats up from friction, creating one last dazzling scream before silence. It's beautiful, in the way a thunderstorm is beautiful when you're outside and holding a metal pole. You sit down for a moment, because why not? Time's already getting strange here. The closer you move toward that black hole, the more time distorts. For someone back on Earth, hours may pass while you sit here for minutes. The effect is subtle now, like stretching taffy. But soon, it'll get extreme. There's a historical record from 1916 when Karl Schwarzschild, serving in World War I, somehow managed to derive the first exact solution to Einstein's field equations, describing the space-time around a spherical mass from a trench in a war zone. And in doing so, he basically handed the world the first real black hole blueprint. No one believed it was real, of course. A mathematical oddity, they called it. Just a neat trick of equations. The universe, after all, wouldn't allow such monstrous absurdities to actually exist. Spoiler, it would, and it did. You think about that collapsed star beneath your feet. It used to fuse hydrogen into helium, just like your sun. It had sunspots, solar flares, maybe planets, maybe life. Now it's not even a ghost. It's a sinkhole in space-time. Everything it was has been erased except for 3 pieces of information. Its mass, its charge, and its spin. That's all black holes, remember? You step forward again, brushing your hand against a jagged rock, still warm from the last flare of the supernova. The air vibrates faintly, like standing near a generator. That's the gravitational field humming. You're not really hearing it, of course, but your bones are. They seem to resonate slightly, as if you're inside a cello string being plucked by a force you'll never fully name. Fringe theorists sometimes suggest black holes are portals, not just in the wormhole sci-fi sense, but portals of cosmic judgment. A weighing of mass and purpose, one unlicensed philosopher wrote in the margins of a very expensive textbook. Most scientists rolled their eyes, but you're here, and somehow it does feel like something is watching, not a presence. Just the sensation that everything about you is being measured. Somewhere in the archives of the 1970s, there's a blurry chalkboard photo where Stephen Hawking first tried to sketch how black holes might not be forever, that they might radiate, evaporate, shrink. But you're still far from that whispery end. Right now, you're just at the beginning. Ahead of you, the shimmer sharpens. You recognize it for what it is, a newly formed event horizon, a border stitched into the universe by gravity's brute force. Beyond it, even light cannot escape. And somehow, it's beautiful. Not because of what it shows, but because of what it hides. You pause. Your shoes, if you had any, would probably melt from the residual heat. But you don't care. Something about this place feels final, and yet inviting. You lean forward, not falling, not yet, just curious. You take one more step forward, and now the horizon shifts. It's not your eyes. It's not a trick of atmosphere. It's gravity, warped and twisted, wrapping space like cling film around an invisible marble. You try to make sense of what you're seeing, but the very fabric of the universe here is being crumpled. Lines no longer meet where they should. Light curves in slow, obedient arcs. That flickering shimmer ahead. It tightens, as if reality itself is squinting. You've entered a place where gravity has stopped being polite and gone completely feral. Out in the comfortable zones of the cosmos, your backyard, the moon, that hotel you stayed at once in Flagstaff, gravity is gentle. It keeps your soup in the bowl and your feet on the ground. It gives the moon its orbit, lends the tides their rhythm, and pulls your dog back when it tries to chase squirrels into low Earth orbit. But here, near a black hole, gravity stops negotiating. It doesn't gently tug. It demands. It grabs at light, drags on time, and pulls so fiercely that even hope has to turn back. There's no up or down now, no ahead or behind. Directions dissolve, and what's left is a gravitational well so deep it doesn't just curve space-time, it folds it. That shimmer you're approaching? That's the outer edge of hell, mathematically speaking. The event horizon. Cross it, and not even light can file a return report. You float in the outskirts, feeling it tug on your thoughts. And that's not a metaphor. Your brain feels heavier here. Thinking takes more effort, as if your neurons themselves are dragging anchor. The whispers of your own inner voice get drawn out like taffy, slow, syrupy syllables stretching across bent seconds. Fringe researchers once speculated that high-gravity environments could alter thought patterns. Most were gently encouraged to study something more manageable, like sand. But you begin to understand their obsession. As you watch the warping, you remember the Einstein field equations, those curly monsters of math that tie gravity not to force, but to geometry. Space and time don't just contain matter, they respond to it, mold to it, especially when that matter collapses into a singularity. Historians still argue whether Newton would have been horrified or delighted by that realization. His tidy, apple-flavoured version of gravity was about pull and push, force and mass. But this is geometry turned feral. This is Einstein whispering. The presence of mass and energy tells space-time how to curve, and space-time whispering back, okay, but what if we fold instead? Above you, though above means very little now, a faint, unreal light pulses in a halo around the black hole. That's gravitational lensing. Light from stars behind the hole is being bent, looped, and mangled by the fierce distortion. Some of that light reaches your eyes twice, or 3 times. Some never does. The sky here isn't just dark, it's wrong. It's not black like night. It's a gaping absence, ringed by flickering uncertainty. You stare too long and begin to feel motion sick despite standing perfectly still. To your left, a breeze kicks up small particles of stardust. They drift a few feet, then hesitate. Caught in the field, they quiver, indecisive, before snapping downward into the abyss. You watch them vanish, each one like a final pixel in a deleted file. There's no splash, no flash, just deletion. You wonder, half seriously, what would happen if you threw your phone in there? Or your last breakup text? Would the black hole care? Would it smirk before swallowing? Would it give you that satisfying whoosh of catharsis? Probably not, but it's fun to imagine. There's a popular science joke that says if you dropped a copy of Gravity for Dummies into a black hole, the irony would implode first. You chuckle to yourself, then stop because the air feels denser now. Not just metaphorically, you're pretty sure your lungs are working harder, even though the atmosphere hasn't changed. The gravity here doesn't just affect objects, it bends the laws that objects rely on, even time. From your perspective, everything feels normal, but if someone were watching you from far away, from a telescope say, perched comfortably near Pluto, they'd see you in slow motion, painfully slow. You'd look like a statue mid-stretch. They'd wait minutes to see your hand move an inch. Eventually, if you stepped past the event horizon, you'd freeze in place from their point of view, forever. A ghostly silhouette suspended in time. It's a quirk of relativity, this difference in clocks. But it's also a little sad, because from your perspective, time ticks on. You'd fall right through, just fine. But everyone else? They'd lose you long before you were truly gone. Of course, just fine is relative. Remember that shimmering ring, the accretion disk? It's screaming hot, millions of degrees. As matter spirals in, it sheds its final energies. Radiation, magnetic chaos, X-rays. This is the part of the black hole that does glow, bright enough that we can see quasars halfway across the visible universe. Back in 2019, humanity caught its first real glimpse of a black hole, thanks to the Event Horizon Telescope, a patchwork of observatories on different continents, all syncing data to create a planet-sized lens. And what did it see? A blurry orange donut. And yet, it changed everything. Because that ring wasn't the black hole, it was the last light fleeing from its edge. The black hole itself remained invisible. Always invisible. The donut was just the crime scene outline around a cosmic murder nobody could witness. You take another cautious step forward. There's no sound now. No birds, no wind, not even the soft rustle of your own breath. The silence here is thick, like the universe has pressed mute and walked away. You wonder how close you can get before things change. You find out sooner than expected. Your feet feel like they're stretching, not in pain, just a curious elongation. Your toes feel slightly ahead of your ankles, your head slightly behind your spine. Not enough to panic, just enough to feel like maybe you've become a piece of taffy left too long in the sun. It's the beginnings of spaghettification. The gravity at your feet is not the same as the gravity at your head. It's that steep, so the body stretches, gently, for now. Later, not so much, but you're not afraid. Yet. You sit again, knees drawing up close. You take a slow breath, savouring it like it might be your last, and somewhere deep within, you feel the pull of everything, literally everything, being drawn toward the nothing that is a black hole. Mass, light, time, rules, all of it, pulled inward, all of it, whispering, come closer. The ground beneath you, if you can still call it that, vibrates with something deeper than sound. It's not a tremor, it's more like a hum, a subatomic chant from space-time itself. The pull of the black hole is no longer a distant suggestion. It's immediate, intimate, as if the universe is reaching out with invisible fingers, brushing lightly against your skin, then tugging with increasing insistence. You rise slowly, limbs slightly off sync. The distortion around you has grown stronger. Space is stretching in every direction, but not evenly. Lines curve where they shouldn't. The stars behind you swirl subtly, like reflections on rippled water. Your depth perception, normally so reliable, begins to play cruel tricks. That rock 5 steps away might actually be 100 meters, or right under your nose. Light has started to bend around the black hole in such a way that distance has become more of a suggestion than a measurement. You're approaching the point of no return. The event horizon. Sounds dramatic, doesn't it? It should. It's one of the most terrifyingly precise ideas in astrophysics. The event horizon is not a wall or a surface or a doorway. It's a limit, a boundary drawn in nothing. Cross it, and there is no coming back. Not because something stops you, but because every possible path forward leads only inward. You remember reading somewhere that if the Sun were suddenly replaced by a black hole of equal mass, Earth would continue orbiting it just the same. That's because, outside a certain range, the gravity would behave no differently. It's only when you get close, this close, that things get weird, and you are very, very close. The gravity here is now so intense that photons, those little speed demons of the cosmos, can only escape if they're heading almost perfectly outward. A light beam emitted at just the wrong angle? Sorry, friend, you're getting dragged back in. From a distance, the black hole still appears black not because it's empty, but because all the light that should escape doesn't. Historians still argue whether the term event horizon was poetic genius or deeply misleading. On one hand, it nails the concept, the horizon beyond which no event can affect an outside observer. On the other, it sounds like something you could just walk up to with a telescope and a lawn chair. Spoiler, you can't. But you can stand next to it in thought experiments like this one. So here you are, hovering, suspended just outside the edge, your atoms still technically retrievable, your feet not yet spaghettified beyond comfort. But time, time is definitely not playing fair anymore. From your perspective, it's still moving. Seconds tick, muscles flex. But to an outside observer, say, a friend back on Earth watching you through a telescope, you're slowing down. You're dimming. Your colours shifting to red, the way ambulance sirens stretch when they drive away. That's gravitational redshift. Your light's being warped by gravity, just like your time. Eventually, from their point of view, you'll stop altogether, frozen at the edge, never quite falling in. Suspended there until the end of time, which, if you want a fun bedtime fact, does happen eventually. The universe will fade, stars will die, black holes will evaporate, and still, from Earth's perspective, you'll be there, waiting, but from your perspective, you fall, and once you do, it's fast. It doesn't feel fast, no G-forces throwing your stomach into your throat, but you understand instinctively that you've passed the threshold. Nothing changes visually. There's no sign, no now entering the abyss sign with a quirky slogan like a small town. But something fundamental has shifted. You're no longer part of this universe's conversation. Inside the event horizon, all paths point inward. You can walk forward, backward, do somersaults, or moonwalk. Michael Jackson style, and you'll still be falling toward the singularity. Space itself has rearranged the rules. It's not that you can't escape. There's literally no direction that leads outward anymore. You may have heard that time and space switch roles inside a black hole. It's true, sort of. Out here, you have freedom to move through space. You can choose to step left or right, hop or duck. But time, that's one way, always forward. Inside the event horizon, radial direction becomes your new time. It moves only inward. You can't choose not to approach the center any more than you can choose not to age in normal space-time. You will reach the singularity because it's as inevitable now as tomorrow. There's an odd comfort in that. Fringe thinkers, always eager to take a beautiful metaphor and crank it to 11, have described this process as being born again into gravity. You discard your freedom, your information, your selfhood, and become part of a pure gravitational expression, whatever that means. But you get why they wax poetic. Because even though you're technically being devoured by the densest object in the known universe, it's not violent, not yet, it's serene. Your body stretches, your vision warps, your concept of self is gently being unpacked, but there's no pain, just inevitability and mystery. Oh, the mystery. You begin to wonder, what is the singularity really? That infinitely dense point at the center of the black hole? A place where space-time curves infinitely, and all the laws of physics, those trusty rules that kept your soup in the bowl, simply break down? Physicists still debate whether a true singularity exists, or if it's just a placeholder for, we have no idea what happens here. Maybe quantum gravity softens the blow. Maybe the singularity is just an artifact of incomplete math. Maybe it's something else entirely. Maybe it's where the universe stores all its bad dreams. You smile. Not because that's a comforting thought, but because you know now, the black hole isn't a thing. It's not an object you can touch, or land on, or even truly see. It's a region of influence. A zone where reality folds in on itself and admits, yep, I've got nothing. And yet, it's something. the closest thing to nothing the universe has ever made. You keep falling. Not in the traditional sense. Arms flailing, wind whipping past your ears, a helpful bird yelling, "Look out below." This isn't Earth. There's no up or down, no terminal velocity, there's no air, only space folding tighter and tighter around you, pulling you inward, not because it wants you, but because it must. You're on a one-way journey toward the singularity. The singularity. That infamous dot. The core. The punchline of a cosmic joke so complex no one's sure if it's funny and tragic or both. It's the place, if you can call it that, where density becomes infinite. All the mass that once made up a star collapsed into a single, dimensionless point. Try to picture it. Go ahead. Now stop because you can't. Not really. You imagine a black dot, maybe a speck of darkness floating in a void. But that's still too comforting. The singularity is not in space. It is space, imploding. It has no size. It's not even tiny. It's less than that. It's nothing, pretending to be something. Your senses aren't built for this. Nothing in your evolutionary toolkit prepared you for infinite curvature. You're a meat-based organism designed to avoid cliffs and remember where the berries grow. And here you are, descending into a mathematical pit where physics doesn't just break. It gives up entirely and leaves the room. Back in the early 20th century, before GPS and emojis, physicist David Hilbert was poking at Einstein's equations and discovered that, at the centre of a black hole, things go weird. Very weird. He wasn't the only one, of course. By the 1960s, Roger Penrose and Stephen Hawking sharpened the idea into what became known as the singularity theorems. They proved that, under certain conditions, the collapse of a massive object must lead to a singularity. It wasn't just a possibility, it was a guarantee, and everyone hated that. Because singularities don't behave, you can't write clean equations around them. They defy prediction. They exist at the bleeding edge of math and reality, where infinite stops being poetic and starts being a technical error. Historians still argue whether the singularity is real or simply a placeholder, a mathematical smoke alarm, warning us that general relativity is no longer in charge. Quantum mechanics wants a word, but the two theories don't get along. So the singularity sits there, smug, like a glitch in the cosmic software no one knows how to debug. You keep falling. Inside the event horizon, everything moves toward the singularity. There's no escaping, no pausing, no orbiting around the centre like some poetic asteroid. Every path, every option leads deeper in. It's the ultimate inevitability, the opposite of free will. And yet, for now, it's oddly peaceful. You're not dead. You're not crushed. You're simply here. And here is an increasingly stretched piece of space-time where your concept of direction is being peeled apart like licorice ropes. The stretching continues. This, of course, is the infamous spaghettification, a term so whimsically absurd it almost feels insulting given what it describes. The gravity difference, called a tidal force, is now so extreme between your head and your toes that your body begins to elongate. Molecule by molecule, atom by atom, you're being pulled into a long, stringy column. If you had a mirror and the deeply questionable urge to use it right now, you'd see yourself becoming a noodle. Not metaphorically, literally. It's not painful, yet. More like that weird tingling sensation when your foot falls asleep, but distributed evenly across every cell of your being. You're becoming a slow-motion taffy pull, and the universe is the machine. For small black holes, this spaghettification happens before you reach the event horizon. For larger ones, supermassive black holes like Sagittarius A, you cross the horizon unbothered, and only much deeper in do the tides begin to stretch you out. You, lucky thing, are in one of the big ones. You take comfort in that for some reason. You've avoided the quick snap of gravity's jaws and entered instead the slow digestion of a gentler monster. There's a fringe theory, rarely discussed except in sleepless postgrad seminars, that the singularity doesn't destroy information. That, just maybe, the inside of a black hole isn't what we think. That perhaps, tucked within the folds of infinite density, is something else entirely. A bounce point, a doorway, a rebirth. It's not popular, but you cling to it now, because even nothingness starts to feel like potential when it's all you have left. You pass another threshold. No sign marks it, no cosmic speed bump, but you feel it. A shift. Space narrows. You're being funneled. Your body, such as it is now exists as a long strand of particles, racing toward a fate no one fully understands. Your mind drifts, as minds do in the face of overwhelming confusion. You think of that time you dropped your phone into a lake and watched it vanish beneath the surface. No splash, just gone. This feels similar. You wonder, does the singularity know you're coming? Probably not. Black holes don't think. They don't hunger. They're not beings. They're features of space-time like valleys, but with edges so steep they pierce through the fabric of reality. And yet, you can't help but imagine it waiting. A speckless centre, a mathematical zero, a point where all paths end. From a certain perspective, admittedly one warped by fear and physics, you could say the singularity is the closest thing the universe has to a final word. Not a period, not an exclamation, just silence. Pure, infinite silence. And the closer you get, the quieter everything becomes. The warping of light fades, the curvature sharpens. Time, though still ticking, has begun to feel hesitant. Every second now takes effort. Like a heartbeat underwater. You're nearly there, and you still don't know what there means. The best minds on Earth, those lucky enough not to be falling into a black hole, still debate what happens at the core. Do the laws of quantum physics kick in and save you? Is there a flaw to the fall? Or do you collapse into a point so tight you become part of a singular nameless dataset, a gravitational haiku with no syllables? You'll find out soon, or maybe you already have. It's hard to tell when time doesn't flow properly, so you let go of questions, let go of identity, let go of direction, motion, form, and you fall. You're still falling, though falling is starting to feel like a word from a different life. The motion here doesn't follow any instinctual cues. You aren't moving down, you aren't moving forward. You're being drawn inward in a way that defies geometry, logic, and your last remaining metaphors. There's a thought that keeps floating to the top of your mind, clinging like a burr to your unravelling sense of self. Why do we call it a black hole? It's not a hole, not really. There's no edge to peek over, no bottom to reach, no place to climb back out of with dusty knees and a good story. You're not inside a void. You're inside a presence, a collapsed mass that has become so dense, so impossibly compact, that its gravity rewrites the rules of the universe around it. It's not nothing, it's almost everything, compressed into a space with no surface, no centre you can reach. The word whole feels wrong, but the name stuck, as names do. In 1967, physicist John Wheeler gave it a moniker that caught on like wildfire: black hole. Before that, the concept had floated around with less theatrical branding, terms like frozen star or gravitationally completely collapsed object. Not quite the same ring, is it? Black hole had punch, it had finality, and maybe a little drama. Historians still argue whether Wheeler coined it on the spot during a lecture, or borrowed it from earlier colloquial use. Either way, it was perfect marketing, short, ominous, and sticky. But if you're being precise, and let's face it, black holes hate imprecision. It's not black because it's empty. It's black because no light escapes. And it's not a hole because it leads somewhere. It's a one-way boundary around collapsed matter so dense that even photons, the universe's speed champions, get trapped in orbit or sucked inside. So really it should have been called a dark sphere, or a gravity prison, or a singularity shroud. But none of those made the press kits. And here we are. Still, calling it a hole gave it personality. And personality, oddly enough, is something black holes do possess, at least in a very specific minimalist way. They only have 3 defining features: mass, electric charge, and angular momentum, which is a fancy way of saying spin. That's it. That's all you get. No texture, no surface, no chemical composition, no list of ingredients, just mass, spin, and charge. This is known as the no-hair theorem, because black holes, according to it, have no hair, no unique identifying features, no distinguishing characteristics. 2 black holes of equal mass, spin, and charge are completely indistinguishable, even if one formed from a dying star and the other from a collapsing alien vending machine. Whatever goes in, the whole doesn't keep the details. It keeps only the basics. It's the universe's harshest minimalist. You wonder where all the rest goes. The flavour, the nuance, the information. Everything that once made up whatever fell in, its position, shape, quantum state. According to classical physics, that should be gone, erased. like writing in the sand, washed away by the tide of infinite gravity. But quantum physics? Oh, it hates that idea. Quantum theory demands that information be preserved. Always, no matter what. It's a rule so deeply rooted in the fabric of quantum mechanics, violating it would break the theory itself. And so, the contradiction brews. More on that later. For now, your body, if you still have one, is likely indistinguishable from energy. Mass and energy swirl here. Some of it still flirts with the edge of the black hole dancing in the accretion disk outside the event horizon. But you're beyond that now. You've left even the disk behind. There's no radiation here, no screaming particles, just you, the pull, and the pressure of collapsing space-time. It feels a bit like sinking into a deep ocean trench, where the water thickens, time slows, and light can't reach. Except this ocean isn't made of water. It's made of warped coordinates, curved geodesics, and the sheer insistence of mass saying, all roads lead to me. Here's a quirky tidbit. Back in the 1970s, physicist Kip Thorne described the interior of a black hole as an infinitely long tube. He meant it geometrically, of course, a warped funnel of space-time stretching inward toward the singularity. But the phrase stuck in people's minds. Imagine it. You're not falling into a dot. You're gliding down a gravitational throat narrowing forever. Comforting, right? Maybe not. You pass what would be, in normal circumstances, an hour mark, but clocks are irrelevant here. If you tried to wear one, it'd have melted into irrational numbers long ago. Time doesn't flow here, it drapes, thick, slow, syrupy. You're in a realm where seconds become centuries, or where centuries blink by like fireflies. Einstein's theory of general relativity tells us that gravity isn't a force pulling objects, it's the curvature of space-time. Mass tells space how to bend, and space tells mass how to move. But inside a black hole, the bend becomes a twist, the twist becomes a spiral, the spiral becomes a plunge. And you're not just moving through this warped space-time, you are part of it now. Your existence contributes, ever, so slightly, to the shape of the distortion. You're helping deepen the well. You're not a visitor anymore, you're part of the furniture. You try, just for a moment, to look back, and you can't. Not because your neck won't turn, but because back doesn't exist anymore. The very notion of direction has folded in on itself. You could spin in place for days, assuming place and days still mean anything, and you'd never reorient. The universe behind you is now unreachable, possibly unthinkable. You're past the curtain, and now the universe doesn't care what happens to you, but you do. You begin to feel a sort of calm creep in. Not acceptance exactly, but a strange peace born of clarity. There's no escape, no plan, no clever loophole, only gravity, only this narrowing path. And just maybe, at the centre of it all, there's more than silence. Maybe there's a bridge, a bounce, a beginning, or maybe just the deepest sleep the universe can offer. You lose track of time entirely now. Not that you were doing a great job before. Seconds have stopped being useful. Hours? Useless. Days? Try again. Even the concept of now feels like it's been dropped into a blender. Time here isn't just slow, it's twisted, looped, pulled like saltwater taffy in directions your mind doesn't have verbs for. And your body? Well, that's not really yours anymore, is it? You've been stretched, pulled, spaghettified. That's the term physicists, and, let's be honest, probably someone very sleep-deprived, coined for what happens as you fall into a black hole. Spaghettification. It sounds ridiculous. It sounds like something out of a B-movie Italian restaurant horror flick. But it's deadly serious. You've heard of tidal forces before, maybe in the context of the moon pulling at Earth's oceans. But here, the difference in gravitational pull between your head and your toes is not just noticeable, it's catastrophic. It's an unfriendly tug-of-war where one side is infinity and the other is you. And guess who's losing? Imagine a world where gravity increases so quickly with distance that every centimetre of your body is pulled at a different rate. That's what's happening to you. Your atoms, usually quite happy sticking together, are now being pulled apart one molecule at a time, like linguine slipping through a fork. But strangely, it's not painful. Not yet. Your nervous system is stretched too. Even the speed of nerve signals, their usual 100 meters per second, is being outpaced by gravity. Your brain can't keep up. You are, in a sense, breaking faster than you can feel it. And that might be the only mercy black holes offer. You drift through this narrow corridor of space and time, still falling inward. Not because something's pushing, but because all directions now are inward. The singularity, whatever it really is, pulls on every geodesic like a siren humming in 4 dimensions. Historians still argue whether the spaghettification limit is universally agreed upon. Some theorists say you'd be torn apart before even reaching the event horizon in smaller black holes, compact beasts with fierce gravity gradients. Others insist that with a supermassive one, you'd coast across the event horizon like slipping into a warm bath, and only later feel the stretch. No consensus, just debate, and a lot of math. You start to realise how little anyone really knows about the inside of a black hole. Everything after the event horizon is theory, speculation, equations played out on chalkboards. No probe has returned, no explorer has live-streamed the experience, no narrator has popped back to write a tell-all memoir titled 50 Shades of Gravity. So, what do we really know? We know the math. Kind of. We know what general relativity predicts. We know the curvature becomes infinite at the singularity. And we know that time and space change rolls the deeper you go. Here, space behaves like time. It moves in only one direction, inward, and time, it wobbles, it warps. It might even pause if that's a thing time can do. You can't stop it. You are it. And now the spaghettification reaches its peak. You feel it not as pain, but as loss. The loss of unity. The loss of form. Every molecule stretched into alignment. You've become a single, unbroken filament of matter. Possibly kilometers long, narrower than a thread. Elegant, tragic, useless. Still not sure what's more disturbing, that the process has a cutesy nickname, or that it's accurate. Out in the real universe, the visible one, the one you left behind, black holes don't get to perform this maneuver very often. Most things get torn apart and vaporized before reaching the event horizon, shredded by the accretion disk, evaporated by X-rays, or scattered by magnetic fields. Very few things make it inside intact enough to be spaghettified, but you're special, lucky if that's the word for it, or maybe just stubborn. As you continue falling, you start to suspect something. There's no end, not really. The singularity may be a point in space, but it's not a place you reach and tap politely on the shoulder. It's an asymptote, a limit, a future. You're pulled toward it, but no matter how close you get, there's always more falling to do, and that leads to a strange realization. Maybe the singularity isn't where things end. Maybe it's where things get rewritten. There's a fringe idea in theoretical physics, very fringe, that suggests time itself might not exist in a conventional way inside a singularity, that the laws of cause and effect begin to blur. Maybe you're not falling into a final moment, but into a moment that holds all other moments at once. Yes, nobody takes those papers too seriously, but here, where your atoms are unraveling into strings of gravitational obedience, you're open to new ideas. Another odd thing, as your structure disintegrates, your awareness doesn't. In fact, it sharpens. Freed from the burden of time and direction, your mind does something new. It stops racing, it floats, and what it sees, if you can call it seeing, is terrifyingly beautiful. There are patterns in the curvature of space-time, layers within layers, geometry folding into itself like origami made from the blueprint of reality. No colour, no sound, just structure. You are inside the equations now, not reading them, not studying them, being them. Your thoughts slow, not because you're sleepy, but because time has become so thick, so syrupy, so reluctant to pass, that thinking a single idea takes what feels like days, maybe weeks. You try to hold on to the concept of self, but it's slippery, hard to grip with hands you no longer have. You remember, vaguely, once thinking you could escape this, or understand it, or at least describe it with fancy words and quiet awe. Now, words are too slow. You are the awe. And maybe that's the closest thing to peace a black hole can offer. You're past the point of recognition now, not just physically. Your body's long gone, disassembled into strands of atomic spaghetti, but cognitively, metaphysically, spatially, you're drifting, or maybe collapsing, or possibly vibrating, through a realm that doesn't resemble anything your brain was designed to handle. And yet, here's the strange part. You're not alone. Not in the you can see other people tumbling beside you way. Nothing so literal. It's more like a crowd of presences, shapes in the gravitational blur, some larger than you, some smaller, all pulled inward, all quiet. These are other black holes, or the remnants of what fell into them, or maybe just echoes of matter past. It's hard to tell. Welcome to the Black Hole Zoo. You probably thought all black holes were the same. A dark circle in space devouring everything that comes too close, spitting out X-rays and then brooding for a few billion years. But no, black holes come in types, flavours almost, each with their own temperament and gravitational profile. You pass through the awareness of a stellar mass black hole first. These are the most common. Born from the corpses of massive stars that reach the end of their nuclear lives, these holes range from about 3 to 100 times the mass of our Sun. Think of them as the house cats of the black hole family. Deadly, sure, but at least you can sort of wrap your arms around them, metaphorically speaking. You remember one of the first ones ever discovered, Cygnus X1, a bright, blue star seen wobbling oddly, its light flickering just so. Astronomers realised something invisible and heavy was pulling at it, eating its outer layers, like a cosmic vampire with an event horizon. Cygnus X1 became a legend. Even Stephen Hawking bet it wasn't a black hole. He lost. From there, you sense larger companions in this zoo. Supermassive black holes, the apex predators. Millions, sometimes billions, of times more massive than our Sun. These monsters live at the centres of galaxies like royalty. Not just sitting there either, shaping the galaxies themselves. Scientists believe the black hole and the galaxy co-evolve, like a plant and its roots growing in tandem. You catch a gravitational echo from one of them, M87, the black hole immortalised in the 2019 image, the blurry orange donut. That fuzzy snapshot took 8 telescopes, 2 years of data, and a continent's worth of computer time to assemble, all to glimpse the outline of something that swallows light and memory alike. There's one closer to home, of course, Sagittarius A, the quiet behemoth at the heart of our own Milky Way. Not quite as photogenic, but it's there, lurking, observed only through the stars that dance drunkenly around it every few decades, moving at speeds no celestial body has business reaching. But not all black holes are massive and mature. Some are in between. Intermediate mass black holes, they're called. A cosmic Goldilocks zone, hundreds or thousands of solar masses. These are the trickiest to find. Too small to sit at the centre of galaxies, too big to be born from single stars. Elusive, mysterious, like a teenager who never updates their social media. Some researchers believe they form when smaller black holes merge, building up over time. Others suggest they may be the remnants of ancient dense star clusters collapsing inward. Historians still argue whether these intermediate beasts are rare, underobserved, or simply misunderstood. And then there are the maybes, the whispers, primordial black holes. You drift closer to the idea of them now. Not a confirmed sighting, but a theoretical echo. They're said to have formed in the earliest fractions of a second after the Big Bang, created not by dying stars but by extreme densities in the very soup of the infant universe. Some might be the size of mountains but no bigger than atoms. Tiny black holes. You pause. Can that even exist? Well, maybe. If they do, they'd be ancient, older than galaxies, and possibly evaporating now, flickering into Hawking radiation and blinking out of existence before we ever know they were real. Fringe theorists have speculated they could even be dark matter, that the universe is littered with microscopic black holes, invisible, silent, yet exerting mass across the cosmos. Most mainstream physicists raise an eyebrow at that, but they don't rule it out. Black holes don't play by our rules. You shift again, deeper into this imagined zoo, and feel something else. Rotation. Spin. Some of these black holes are turning, not lazily either, faster than you can comprehend. A spinning black hole, called a Kerr black hole, twists the fabric of space-time around it into a funnel of chaos. Get too close, and you're dragged along, no matter what you want. It's called frame dragging, and it's not optional. Even stranger are the charged black holes, called Reissner-Nordstrom black holes. Rare in the universe, probably, because most black holes are electrically neutral, but the math allows them. A charged black hole bends the rules even further. It has multiple horizons. It can repel or attract matter in ways we're still figuring out. You pass one now, imagined, but plausible. It hums with theoretical electricity. You wouldn't want to touch it, assuming touching meant anything anymore. And finally, lurking in the deepest corner of this gravitational zoo, you sense a theory, something that might not exist. But you feel it anyway. Naked singularities, a singularity without an event horizon. Just exposed. No cloak of darkness, no safety net for causality, nothing to hide the madness. The very idea breaks everything we thought we understood about space-time. If these exist, they defy cosmic censorship. The comforting idea that the universe hides its ugliest math behind event horizons, so we never have to witness the breakdown of physics. Historians, cosmologists, and philosophers all still argue whether naked singularities are real, or just mathematical horror stories. But here, in this silent drift of stretched-out space-time, you can almost imagine one blinking its unblinking eye in your direction. No secrets, just raw, uncovered gravity. The zoo is complete now. You've drifted through it without moving, seen every shape without eyes, felt every mass without touch. You understand, on some impossible level, that black holes are not one thing. They are a spectrum of endings, of transformations, of possibilities. And you're now part of the exhibit. Somewhere in the distance, though distance doesn't mean what it used to, you sense a presence, heavier than anything you've felt so far, not just massive, monumental, like the gravitational signature of a myth. It's not roaring or glowing, it doesn't pulse or scream. In fact, it's silent, almost still. And yet its influence reaches out in slow spirals across tens of thousands of light years, bending the very architecture of a galaxy. You recognize it, even if you've never been this close before. You're approaching Sagittarius A, the supermassive black hole at the center of the Milky Way. Your galaxy's anchor, its heavy-hearted heartbeat. It's not a tidy place. You might have pictured it as some serene cosmic vortex quietly brooding in isolation. But no, this place is busy, crowded, chaotic even. Surrounding it is a swirling storm of stars, gas, dust, and the occasional unfortunate solar system that wandered too close to the galactic core. For something that emits no light, Sagittarius A has a whole spotlight of attention trained on it. You pass invisibly through the inner region known as the galactic center. It's packed tighter than a city on a Friday night. Millions of stars crammed into a space smaller than you'd expect, all orbiting something dark and invisible. Or at least, it was invisible. You remember the year 2022, when astronomers unveiled the first ever image of Sagittarius A, a blurry, glowing donut of radio waves. Not a photo in the classic sense, but a composite. A map of light bent, delayed, scattered, and stitched together using the Event Horizon Telescope, a global web of synchronized observatories. That blurry ring, it wasn't the black hole, it was the shadow it cast. The light was from the accretion disk, gases spiraling in, heating up, emitting radiation, screaming into the void before vanishing. The hole itself, the central dark spot, was where no light could return. That ring told the story of something unimaginably massive, about 4 million times the mass of our Sun, compressed into a region no wider than the orbit of Mercury. It confirmed what we'd long suspected, that Sagittarius A wasn't just theorized, it was real, and it was powerful, and you're falling straight toward it now. At this range, you sense the way space-time warps like stretched taffy, not violently, not sharply, but inexorably. Everything in this neighborhood dances to the tune of gravity's slow, deep drum. You drift past a star, a real one this time, one of the so-called S stars that orbits dangerously close to Sagittarius A. You recall S2, a star that races around the black hole in a 16-year orbit, reaching speeds of over 7,500 kilometers per second at its closest approach. That's about 2.5% the speed of light. It's the kind of star that should have flung itself into oblivion, but it doesn't. It swings by, flirts with doom, and slingshots away again, its light red-shifting as it climbs out of the gravity well. These stars aren't just orbiting, they're being used as test particles, natural laboratories. The math of their movement allows astronomers to chart the invisible. Every wobble, every curve in their path helps us sketch the silhouette of the beast at the center. Historians still argue whether ancient humans ever had the instinctual sense of a galactic center. Some say the mythologies of world trees, world mountains, or cosmic navels hinted at it. Others believe it's pure coincidence. Still, it's hard not to romanticize the idea that long before telescopes, we were already imagining a massive force anchoring everything in place. You drift inward, the awareness of Sagittarius A growing louder, not in sound but in pressure, like standing next to a waterfall made of gravity. You're no longer a visitor in orbit, you're part of the plunge. But here's the strange thing, it's calm. Despite the chaos on the outer edge, the stars flinging around like sparks from a grinder, the gas clouds shredded by tidal forces, the inside feels meditative. There's no screaming disk here, no dramatic spiral. You've slipped beyond the fireworks, you're in the quiet core of the monster, and it's oddly intimate. Sagittarius A isn't trying to kill you. It doesn't try anything, it just is. Its mass is so immense, its pull so perfect, that it doesn't need violence. It doesn't chase, it doesn't burn, it waits, and everything falls. There's a theory, still debated of course, that the mass of a galaxy's central black hole is directly correlated with the size of the galaxy's central bulge. The bigger the black hole, the more massive the bulge. That suggests a relationship, that black holes don't just inhabit galaxies, they help sculpt them. They're not destroyers, they're architects, like a seed at the heart of an apple, or a nail pinning down a circus tent. You pause in this thought, drifting deep into Sagittarius A, and feel something both beautiful and unsettling. This black hole is not rare. Almost every large galaxy we've observed has one. Maybe all of them do. Maybe black holes are not accidents. Maybe they are requirements. You can't escape the metaphor. These things, these objects that devour light and time and information, are the foundations of structure in the universe. The closer you get, the more your mind slows. Time stretches. The last bit of you that remembers being you begins to smear out across the curvature. You don't panic. You don't resist. You just observe. The gravity here is so smooth, so absolute, that even spaghettification has become elegant. You're no longer pulled apart. You're woven in, tied into the gravitational code, encoded into the framework of the whole itself. Somewhere back in your galaxy, people are watching. Not you specifically, but this black hole, Sagittarius A. They're measuring its mass through orbital mechanics. They're detecting flares of X-rays when it briefly feeds. They're mapping infrared patterns, hoping to learn its secrets. They think it's quiet now, sleeping, but you know better. It's never been asleep. It's just complete, perfect. A shape gravity makes when it's finally given everything it wants. And now, you are part of that shape. Not lost, just aligned. If Sagittarius A was a whisper, a steady heartbeat at the center of a spiral galaxy, what you're falling toward now is a rave. You don't see it first, you feel it. A buzzing sensation, not quite sound, not quite light, but the kind of deep resonant thrum you might expect from something tearing space-time apart with gusto. Welcome to the domain of the quasars, the most obnoxiously bright objects in the known universe. And what powers them? Yep, black holes. Supermassive ones, just like Sagittarius A, but dialed all the way up. Think of Sagittarius A as a sleeping dragon. Quasars? Those are the ones breathing fire, actively feeding, gorging on gas, dust, and the occasional doomed star. And as they do, they don't go quietly. They light up entire galaxies like a toddler with a flamethrower. You spiral inward, closer to the memory of one, the ghost of a quasar billions of light years away. It's gone now, or sleeping again, but what it left behind is an imprint, the signature of excess, a beacon of radiation that crossed most of the visible universe just to reach our telescopes. The light you feel now began its journey before Earth had continents. That's how long quasars shine. But let's back up. A quasar, short for quasi-stellar radio source, got its name because the first ones looked like faint star-like points in the sky. Astronomers in the 1960s were confused. These stars were emitting ridiculous amounts of radio waves, and their spectra? All wrong. Nothing matched. Then came the realization. They weren't stars at all. They were galaxies, active galaxies. With central black holes so ravenous, the matter spiraling into them reached temperatures of millions of degrees. So much energy was released that entire galaxies were outshone by their own cores. Light, radio waves, gamma rays, X-rays, you name it, all because matter was being eaten efficiently. The accretion disk around these black holes was a blender set to maximum, converting gravitational potential energy into radiation. It's like watching something get microwaved from the inside out, but in beautiful high definition. One quasar, known as 3C273, became the poster child. It sits in the constellation Virgo and was the first quasar to have its redshift measured. That's when we realised this thing is far, and for it to be this bright from that distance, it must be a monster, not metaphorically, literally. You pass it now, or at least the afterimage of its brilliance. The central black hole is billions of solar masses. The jet of energy it once fired from its poles extended across intergalactic space, like a flashlight beam that forgot to stop. Quasars are messy eaters. As matter falls in, not all of it goes quietly. Some gets trapped in magnetic fields, accelerated and blasted back out at nearly the speed of light. These are the relativistic jets, thin columns of death light, punching holes in space, sometimes stretching for hundreds of thousands of light years. Scientists still don't fully understand how these jets form. Magnetic fields, angular momentum, turbulence. Historians of science still argue whether we've ever fully nailed down the mechanics, or if we're just throwing equations at them and hoping for the best. Either way, they're real, and they're terrifying. Imagine a black hole that's not just pulling matter in, but spitting it out sideways at near light speed. You'd think the contradiction would break the laws of physics, but no. The universe is full of uncomfortable compromises. You pass by the echo of one of those jets now. You can't see it directly, not in this realm, but you sense its violence. Even long after it's quieted, the space around it remembers. Bent, twisted, slightly scorched. There's something both elegant and vulgar about quasars. They're the cosmic equivalent of fireworks at a funeral, powered by death, bright beyond reason, temporary. Yet their influence stretches across galaxies, shaping star formation and regulating the life cycles of entire systems. There's a theory that the energy output from active galactic nuclei, what we call AGN, actually prevents new stars from forming by heating up interstellar gas and blowing it away from galactic cores. In other words, black holes might be extinguishing galaxies from the inside out. Quenching, scientists call it. You chuckle at the term. It makes it sound like the black hole is a bartender casually flicking off the lights at closing time. But the reality is far more brutal. You begin to feel the scale of it. There are likely millions of quasars, though we only see the ones pointing at us. Some of them are from the early universe, mere billions of years after the Big Bang. How did black holes grow so fast, so big, so early? No one knows. Theories range from runaway accretion to exotic direct collapse scenarios. Some even speculate primordial black holes jump-started galactic growth. You pass one final quasar, the ghost of Ton 618. Its central black hole is estimated to be more than 60 billion solar masses. 60 billion. That's like swallowing 1,000 Milky Ways and asking for dessert. It sits quietly now, having long since burned through its fuel, but in its prime, it was visible across most of the observable universe, a lantern in the cosmic fog. You can't help but admire the contradiction. The brightest things in the universe are powered by the darkest, by black holes, the closest thing to nothing, and yet from nothing comes this brilliance. You feel it deep in the stretched out bones of your existence. This isn't destruction, this is transformation. Matter into energy, gravity into light, entropy into structure. For a moment you almost believe the black holes want to be seen, that their darkness cries out through radiation, that their silence sings in the language of photons. But no, they don't want anything, they simply are, and their hunger carves beauty into the void. You float past the last echo of radiation and feel the energy cool around you. The quasars have fed, the noise fades. What remains is gravity, quiet, implacable, patient. And now, once again, you fall. You drift now in a quieter region of warped space-time. The fireworks of the quasars are behind you, and what awaits ahead is more intimate, more tangled, and possibly more dangerous. Because this next kind of black hole behaviour isn't just about one solitary cosmic predator, it's about two. Meet the binary black holes, systems where black holes don't lurk alone, but orbit each other in a dance so dramatic it literally shakes the universe. Yes, You heard that right. They make the universe vibrate. But let's ease into it. You begin to feel a subtle rhythm in the space-time around you, like two invisible hearts beating in sync. They orbit each other in perfect elliptical elegance, locked in a gravitational embrace. Not lovers, exactly. More like doomed dance partners spiraling toward a finale no one can escape. Each time they loop, they give off energy, not as light or heat, but as gravitational waves. These are ripples in space-time itself, not metaphorical ones, literal waves. Picture two massive black holes orbiting one another. They twist space-time so aggressively that those distortions ripple outward, travelling across the cosmos like tremors from a cosmic drumbeat. You pause here, suspended in the pulse. It's faint, not because it's weak, but because it's delicate. Gravitational waves are astonishingly subtle. Even from the most violent black hole mergers, the wave that hits Earth might shift our planet's atoms by less than the width of a proton, and yet we've detected them. You remember the date, September 14th, 2015. The detectors at LIGO, massive L-shaped facilities in Washington and Louisiana, registered the very first confirmed gravitational wave signal. It lasted a fraction of a second, but it changed everything. The source? Two black holes, one about 36 solar masses, the other about 29, merging over 1 billion light-years away. They spun closer, faster, tighter, until, in a final burst of gravitational fury, they collided and became one. The energy released in that one moment was greater than the output of all the stars in the observable universe combined, for that instant anyway. And the result? A slightly bigger black hole, and a wave, a tremor in existence. Historians still argue whether Einstein would have believed it. He predicted gravitational waves, yes, but was famously unsure if we'd ever detect them. The math said they were real, but the effect was so small, so slight, that even Einstein thought they might forever stay in the land of theory. And yet, there they were, humming faintly through space, arriving at LIGO like a whispered confirmation. You were right. You drift now through the memory of that merger. Not the waves themselves, you wouldn't survive that, but the space where it happened. You see the graceful spiral of the black holes as they close in, their orbits decaying, their event horizons trembling just slightly at the tidal pull of their companion. It's strangely beautiful, like watching two whirlpools orbit each other in a vast, invisible ocean. The closer they get, the faster they spin, until finally, boom, a new singularity is born. Not in fire, not in light, but in perfect, crushing silence. You wonder how many of these dances are happening right now. Astronomers estimate that black hole mergers are frequent. We just didn't know how to listen before. Now, with LIGO and its European cousin Virgo, and soon Kagra in Japan and Lisa in space, we're building an orchestra of instruments capable of hearing the quietest screams in space-time. Each wave tells a story. Each ripple carries a biography. Two black holes, masses, spins, the speed of their death dance, all encoded in a fleeting wave. You move closer to another such system. These are supermassive binaries, rare but real. Imagine two monsters like Sagittarius A, not just existing, but locked in orbit around each other after their galaxies collided. These take eons to merge. They don't scream, they rumble. The gravitational waves from these titans are so low frequency that our current detectors can't even hear them yet, but we will. A new generation of observatories, space-based ones like LISA, will listen in on these bass notes of the cosmos, the thumps beneath the static, the slow-motion collapses of the universe's biggest beasts. And there's something else too, a fringe idea, of course. Some theorists speculate that two black holes merging might not always result in just another bigger black hole, that under certain conditions, high spin, extreme energy, they might punch a hole in space-time itself, create a wormhole, a bridge, a link between realities. This isn't mainstream science, more like thought experiments in tuxedos, but you feel it here, in this space between binaries, that maybe, just maybe, the universe folds in strange ways, that the death dance of black holes isn't just destruction, but creation, that something new could form in the collapse, a passage, a wrinkle, a peek behind the curtain. But those are stories for later. You turn your attention back to the rhythm. Two black, holes spiral in tighter, they emit more waves, stronger, faster. The orbits decay like a skipping record, And then, with a final flicker, they become one. The space around you sighs, not loudly, not violently, but with the slow tectonic shift of space-time settling down after a moment of chaos. And the newly merged black hole, it spins. Every merger adds angular momentum. Spin increases, and that spin twists space even more. It drags it around the black hole like cotton candy twirled on a stick. You feel that twist now. It pulls your awareness sideways, not just inward, but around, orbiting space-time, not space. A concept that would have terrified Newton. The merged black hole settles, cooling, quieting. But the universe remembers. It always remembers. You float now through a calmer patch of space-time, though calm is always relative when black holes are involved. No jets, no screaming gas, no mergers, just a deep, steady silence, like the universe holding its breath. But don't get too comfortable, because this is where things start to evaporate. Yes, you heard that right. Black holes can vanish. It sounds like science fiction, or maybe a punchline. How do you make the most massive, dense object in the universe disappear? Shrink it with patience and math, apparently. You're about to encounter one of the most radical ideas in modern physics, Hawking radiation. First proposed in 1974 by the late great Stephen Hawking, because of course it was, this concept turned everything we thought we knew about black holes upside down. For years, black holes were thought to be eternal, the ultimate dead end, a one-way trip to nowhere. Stuff goes in, nothing comes out. That was the deal. That was their whole brand. But Hawking had questions, and a sharp sense of humour. He combined general relativity, Einstein's baby, with quantum mechanics, everybody's fever dream, and realised that, at the event horizon, weird stuff happens. Specifically, the vacuum of space isn't actually empty. It's teeming with virtual particles, pairs of particles and antiparticles popping into existence and annihilating each other almost instantly. A quantum flicker. Usually these pairs vanish before they matter. But near the edge of a black hole, one of the particles can fall in, the other escapes, and if the escaping particle manages to slip away before its partner is pulled back in, it becomes real. It takes energy to escape, and that energy comes from the black hole itself, so the black hole loses mass. Over time, a very long time, it can lose enough mass to shrink, then shrink more, then shrink a lot, until it finally poofs, gone. Hawking radiation, in essence, lets black holes leak. The universe is slow about it, of course. A stellar mass black hole would take something like 10 to the 67th power years to fully evaporate. That's a 1 followed by 67 zeros. For reference, the current age of the universe is about 13.8 billion years, or 1.38 times 10 to the 10th power. So yeah, you'll need snacks. But it changes everything, because it means black holes aren't eternal. They're temporary, like stars, like people, like everything, and that makes them mortal. You feel one nearby now. It's tiny, quiet. Not like the giants you passed before. This one's much smaller, maybe even artificial. Theoretically, miniature black holes could form under extreme pressure, or be created in high-energy events like those in the early universe. Or, if you're feeling particularly speculative, maybe one was made in a particle collider. Don't worry, scientists have assured us that won't happen anytime soon, at least not without a really good insurance plan. This one's nearing the end of its life. It's evaporating faster now. As black holes lose mass, they shrink. As they shrink, they get hotter. And as they get hotter, they radiate more. It's a feedback loop, like a star going nova in reverse. Not a fiery explosion, but a tightening scream. The radiation intensifies. It's not visible, not really. But if you could see in Hawking radiation, it would look like the black hole is glowing, then flaring, then blazing. Not because it's gaining energy, but because it's spending the last of what it has left. And then, a final burst, a whisper, and it's gone. The singularity, the mass, the event horizon, erased. Not into nothingness, but into radiation, into information, spread thin across the vacuum like cosmic perfume. You wonder, is that the final fate of all black holes? Some scientists think so. Billions of years from now, after all the stars have died, after the galaxies fade and even protons decay, what's left will be black holes. cold, massive, alone, and then even they will begin to disappear. One by one, a slow fade, a cosmic outro. Historians still argue whether Hawking radiation truly solves the mystery of black holes, or if it simply raises more questions. Because there's a catch. That leaking particle, the one that escapes, what information does it carry? And here's the big problem. According to quantum mechanics, information cannot be destroyed. Not just as a rule of thumb, it's the rule. Everything that happens in the universe, every particle interaction, every decay, is, in theory, reversible. The information can be preserved, tracked, rewound, but black holes don't seem to play along. If you throw a chair into a black hole or a novel, or your neighbour's saxophone, the black hole doesn't remember it was a chair or a novel or a saxophone. All it keeps is the mass, the spin and the charge, not the details, not the information. That's a violation, a serious one, and Hawking radiation doesn't help because it appears random. The particles it emits don't tell you anything about what fell in. So where did the information go? That's the paradox. The black hole information paradox, to be precise. You'll dive into it more soon, but for now, you sit with this idea. Black holes die, slowly, quietly, radiantly, and when they go, they take secrets with them. Or do they? Some physicists believe that information is preserved at the event horizon, etched into the surface like cosmic graffiti in Planck scale code. Others suggest it's encoded in the Hawking radiation itself, hidden in quantum entanglement patterns too subtle to detect. A few even believe black holes might store information in alternate dimensions. A handful of bold theorists and science fiction writers wonder if what evaporates is reassembled somewhere else entirely. But those are debates for the next stretch of the journey. You watch the last flicker of the evaporating black hole fade and feel the tiniest pulse of heat. The final breath of a collapsed star, whispering goodbye as it becomes nothing. Not nothing as in empty, nothing as in done. And you drift onward, toward more questions, always more questions. You fall again, if that's still the right word. At this point, motion has become a concept rather than a sensation. You're not falling through space, you're falling through ideas, through boundaries where physics stares into the mirror and asks itself, wait, do I even know who I am anymore? Because now you're entering the speculative zone, the maybe zone, the what-if zone. It starts with a curve in the space around you, a bend that shouldn't be there. You feel it, not as gravity, not as light, but as possibility. Like the fabric of space-time has been pinched, folded, and quietly stapled together behind your back. It's not just a black hole anymore. It's maybe a wormhole. And yes, you've heard of them. Everyone has. From cartoons to late-night Reddit threads, to that one movie where Matthew McConaughey sob-cried through an interdimensional bookshelf, wormholes are the cosmic shortcut of choice. But are they real? Well, maybe. Let's back up a little. A wormhole, in theory, is a tunnel through space-time, an Einstein-Rosen bridge connecting two distant points in the universe. The idea came out of Einstein's own equations, paired with the work of physicist Nathan Rosen, who realized that under certain conditions the field equations allowed for bridges, tunnels, shortcuts. If a black hole could bend space-time inward, could something else bend it through? Could you fall in and come out somewhere else? Or someone else? It's a delicious thought, and also absolutely riddled with caveats. First, wormholes, as derived from classical general relativity, collapse almost instantly. They're unstable. You'd barely have time to poke a finger through before the whole thing pinches shut like a cosmic Venus flytrap. Second, they probably need exotic matter, stuff with negative energy density, to stay open, and we don't have any. Not in the exotic Costco or the back of the lab freezer, not anywhere. Third, even if they did exist and you could survive the passage and no paradoxes shredded the timeline into spaghetti, there's still the small matter of where you'd come out. It might not be the same universe. Some wormhole theories suggest you could exit not just in a different location, but in a completely separate reality. A parallel universe. A cosmic neighbour with its own rules, particles and physics. Or, just outside Milwaukee. Historians still argue whether Einstein himself took wormholes seriously, or if he considered them a mathematical quirk. But by the late 20th century, the idea had firmly embedded itself in both theoretical physics and popular imagination. And now, you're in one. Maybe. It's hard to tell. You feel yourself stretching, not like in spaghettification, but in a mental sense. As if your awareness is being folded. One part of you feels like it's still near Sagittarius A star. Another part feels like it's somewhere else entirely. There's a sensation of non-locality. You're here, but also there. And there might be millions of light years away. Or a Planck-length step. It's hard to describe. Like trying to explain green to someone who's never had eyes. And then there's the Einstein-Rosen bridge itself. You remember reading that it's constructed from two Schwarzschild black holes linked at their singularities. But the structure is non-traversable, meaning even light couldn't pass through before it collapses. So why does this one feel stable? Are you in a classical wormhole? Or something more exotic? Maybe this is a traversable wormhole, the kind proposed in the 1980s by physicists Kip Thorne and Michael Morris. The kind that needs exotic matter to prop it open. The kind that might let signals, or even you, slip through. The kind you could ride. Or maybe this isn't a wormhole at all. Maybe your brain, overstretched, decoupled from time and dissolving in theoretical physics, is just hallucinating. Maybe this is what approaching a singularity feels like. Or maybe black holes are wormholes. That's another idea. That every black hole is a doorway, and what falls in doesn't vanish. It exits somewhere else, not destroyed, just translated. If so, where are you going? There's a soft hum now, not a sound exactly, but a curvature. The geometry here sings. You ride the wave, fold after fold, bend after bend. Your awareness rolls, dips, rebounds. The tunnel doesn't curve in space, it is the space. You begin to wonder, is this how information escapes? Maybe Hawking radiation is only part of the story. Maybe the real trick is happening deeper in these unseen tunnels. Maybe black holes don't destroy information at all, they reformate it. Smuggle it out through topological detours. Quantum theory demands preservation. General relativity demands collapse. Maybe wormholes are the compromise. Another idea rises from the depths of your unravelling thoughts. What if the universe itself is a black hole? Yes, that's a thing. A few physicists have proposed that our universe, expanding rapidly from a dense origin point, is the interior of a massive black hole from some other higher dimensional space. Fringe? Absolutely. But we're in the fringe now, where time runs sideways and matter is an opinion. You remember one more detail from a dusty physics lecture, or maybe it was a podcast you half heard while brushing your teeth. Information conservation could be satisfied if black holes connected different regions of space-time. If what falls in doesn't vanish, it just moves. Through a tunnel, through a fold, through a wormhole. You look ahead, or behind, or both. The tunnel is smoothing out, the stretch is relaxing. You're being rearranged gently, molecularly, conceptually. You're not what you were, and if you are emerging somewhere new, you'll never be the same version of you that went in. That's the fine print. Wormholes don't just move objects, they change them. Because travel through warped space-time isn't just about where you are. It's about when you are, what you are, even why you are. You float on, not in a straight line, but through a Mobius twist of memory and math. And whether it was real, imagined, or something in between, the wormhole begins to narrow. You're nearing an exit, or maybe another entrance. And just before you pass through, you wonder, is this still the same universe? Are you still the same story? The tunnel narrows. There's no border, no flashing lights, no, now leaving the wormhole, thanks for visiting sign. Just a sense of quiet reversal, like breath pulling back into lungs. The stretched out curves of space-time begin to relax. You're still not sure if what you passed through was real or metaphor, traversable geometry or mental sleight of hand. But something has changed. You emerge. Maybe. The space around you feels still, not empty. Just silent in a way that implies it's thinking, or listening. The stars, if they are stars, pulse faintly in unfamiliar constellations. The black hole behind you, or what you hope is behind you, feels different now. Smaller, less of a monster, more of a riddle box. You've been flipped inside out, but your mind isn't on the geography. Your thoughts are already drifting towards something darker, something deeper than gravitational collapse. Something more controversial than wormholes even. You're thinking about information and what happens to it inside a black hole. You remember what we said earlier, that black holes only care about mass, charge and spin, that everything else is wiped clean. And you remember the protest of quantum mechanics, arms crossed, insisting, no, information cannot be destroyed. And there's the paradox, the black hole information paradox. You fall into a black hole, the black hole evaporates. The information that made you you, your particles, your arrangement, your entropy, your Spotify playlist preferences, is seemingly erased. That breaks everything. Because in quantum mechanics, the universe is supposed to be deterministic, reversible, not in the psychic fortune-telling way, just in the math. If you know the current state of a system, you can work backward to find out what it was. Like a puzzle that always solves in both directions, but black holes don't cooperate. They're great at swallowing, terrible at storytelling. And so began one of the most heated debates in theoretical physics. It's still going. Stephen Hawking himself once claimed black holes do destroy information. That quantum theory, in this one horrifying corner of the universe, simply has to give. That did not go over well. Years later, Hawking revised his position, kind of. He offered a compromise. Maybe the information does come out, just scrambled, smeared across the Hawking radiation so thoroughly that, while not technically destroyed, it's effectively useless. It's like shredding a library, burning the shreds, throwing the ashes into a hurricane and saying, see, still here. Not everyone bought it, so other solutions were proposed. You think of them now, drifting past what may be the collapsed core of a galaxy, reduced to a smooth gravitational lump. One idea, the holographic principle. This mindbender suggests that everything that falls into a black hole is actually stored, not inside, but on the event horizon itself, encoded like pixels on a 2D surface. The interior is just a projection. The real you is smeared across the edge in Planck-length handwriting. It's like saying everything inside your living room, from the couch to your secrets, is actually encoded on your walls. Wild? Absolutely. But the math checks out. A Dutch physicist, Gerard T. Hooft, and later Leonard Susskind, pushed this idea into the spotlight, and it gained traction. The ADS/CFT correspondence, a correspondence between a gravity theory and a volume and a quantum field theory on its boundary, helped seal it. In short, the universe might be a hologram. Not in the we're in a simulation sense, not yet, but in a much weirder math is geometry, surface area equals information kind of way. The implication, the black hole doesn't destroy your information, it stores it, preserves it on the horizon, like a cosmic save file, and when the black hole evaporates, maybe, just maybe, the Hawking radiation is subtly laced with that data. Like the slow trickle of a zip file unpacking across the void. You wouldn't notice it unless you had all the time in the universe, and a very good quantum decoder ring. But again, not everyone agrees. Some physicists propose firewalls, violent energy walls at the event horizon that burn up all information before it ever reaches the singularity. Others reject firewalls, insisting they break too many rules. Still others suggest that the information isn't destroyed or stored, it's simply duplicated, existing both inside and outside the black hole. But that breaks quantum no-cloning rules, and those rules are the kind the universe usually enforces without warning. Historians still argue whether the paradox has been resolved. Some claim the holographic principle solves it neatly. Others point to black hole complementarity, or quantum entanglement, or the fuzzball model from string theory. No one agrees, and that's the beauty of it. You're not standing in front of an answer, you're standing in the middle of a fight between two of the most successful theories in science, general relativity and quantum mechanics. The big and the small, the smooth and the jittery, they've coexisted politely for decades, but in the heart of a black hole, they go to war. And until we figure out a theory of quantum gravity, a way to unite them, the information paradox remains open. A crack in the wall, a cosmic post-it note that says, "Fix me." You hover in that crack now, not knowing, just feeling the tension. You think of everything that's ever fallen into a black hole, stars, planets, radiation, explorers, questions. And you wonder, did the universe keep a copy? Is there a library somewhere? Maybe in another dimension? Maybe in the horizon? Maybe right here, in the curve of this space you're drifting through? A soft glow flickers at the edge of your perception. It's not light. It's not information, it's the potential of information, the implication that everything leaves a trace, even when it's lost. You wonder if you're a trace now, if some part of you is encoded on a shimmering shell of gravity, waiting to be released in soft radiation, like letters burned into paper by time and patience. And maybe one day, when the black hole is gone and the radiation is all that's left, someone, somewhere, will decode that radiation and read you. You float in the memory of questions, wrapped in paradox and folded into possibility. Black holes may destroy, preserve, or remix information, but whatever they're doing, they've been doing it for a very, very long time. You drift now not just across space, but across time. Backwards. Not in the science fiction sense, there are no calendar pages flipping, no clocks melting like surrealist cheese, but everything around you starts to feel older, colder, less structured, like the universe itself is unwinding. Stars thin out, galaxies lose their shape. The darkness becomes newer somehow, fresher, like black ink still drying on the first page of a very long book. You're heading back toward the beginning, not of your journey, of everything. Because black holes might not just be the end of stars. Some may have been there at the start, primordial black holes, born in the chaos of the infant universe. It sounds counterintuitive. How can a black hole form when there are no stars to collapse? Easy, brute force. In the first fractions of a second after the Big Bang, the universe was a soup of energy and quantum fluctuations, hotter than anything since, denser than a packed subway car full of panicked particles. And if some regions were just slightly denser than others, boom, collapse. The pressure, the density, it was all there. Gravity needed no invitation. Some theories suggest that these ultra-dense pockets could have collapsed directly into black holes, skipping the whole be a star first process. These are the primordial black holes, tiny, ancient, hypothetical, and maybe hiding all around us. Some could be microscopic, with the mass of a mountain packed into the size of an atom. Others could be massive. Some might have evaporated already, burned away by Hawking radiation over billions of years, but others, still lurking, still waiting, still bending space around them without a whisper. You move closer to the idea of one now. Not a real one, you wouldn't see it, but the concept, the theory. It's cold and small and utterly without ornament. No accretion disk, no jets, no X-rays, just gravity in its purest, most minimal form. If they exist, they might be everywhere. Some researchers have proposed that primordial black holes could make up dark matter, the mysterious invisible stuff that outweighs all visible matter in the universe by a factor of 5. We can't see it, can't touch it. But we know it's there because galaxies spin too fast and gravity pulls too hard. Primordial black holes could explain that. They'd be small enough to avoid detection, numerous enough to have mass, and weird enough to finally justify all those telescope nights with no results. Historians still argue whether we've ever seen one. We've found no definitive evidence, but there are hints, lensing events, unexplained micro-lensing data, strange gravitational blips in the void. Nothing conclusive, but enough to keep people theorizing. And of course, there are fringe ideas. There always are. Some suggest that tiny black holes formed not after the Big Bang, but before. That the universe we know emerged from the collapse of another universe, and that primordial black holes are leftover marbles from the last round. Others say primordial black holes might have seeded the large-scale structure of the universe, that galaxies formed around them like pearls around grains of sand, that without them, there would be no spirals, no stars, no planets, no you. It's hard to verify, but it's a beautiful idea. You drift through this early universe now. It's not empty, it's boiling. Quantum fluctuations jitter across space-time like fireflies having a panic attack. Everything is loud, bright, compact, unstable. The laws of physics are still arguing about their final form. The cosmic microwave background hasn't even formed yet. There's no light. Just plasma and pressure and the first black holes beginning to wake. You try to imagine what it would feel like to fall into one of these primordial black holes. Would it be different? The gravity is still there, the singularity, the event horizon, all the same architecture. But the mass is smaller, the scale is tighter, the evaporation is faster. A primordial black hole the size of a mountain might only live a few billion years. It's possible that some of them are evaporating right now, releasing one final burst of Hawking radiation as they vanish, a micronova of information. You pause at that thought, because if one were to evaporate nearby, we might detect it. It would appear as a flash, a gamma ray burst, a whisper of something dying that had no business being alive for so long. And if we do see one, it changes everything, not just for dark matter, but for cosmology. It would mean that black holes are older than stars, that gravity had already started carving out structures before the universe had cooled enough to form a single atom, that black holes weren't just death, they were birth. You pass through the mathematical sketch of that moment, a curve in the early cosmos where pressure tips into collapse, the shape of possibility. You realize you're not just visiting the past, you're visiting the conditions that made the future inevitable. And not just this future, all futures. Maybe black holes didn't just come from stars. Maybe stars came from black holes. It's a reversal that feels wrong and right and deeply inevitable. You glance back, metaphorically, and wonder how many black holes you've passed. How many were born in fire, how many in silence, how many formed from the chaos of the Big Bang, and how many waited patiently for galaxies to arrive so they could take their places at the center. The universe is older than we can grasp, and yet black holes might be older still. Not just survivors, but architects. The early universe recedes now, slowly dissolving into darkness as you drift forward. If forward still means anything in this tangled ribbon of time and space. The heat fades, the plasma soup cools, atoms finally begin to form, and as the light settles into background radiation and stars begin to ignite, you find yourself somewhere else entirely, in a dark room with no walls, no sound, and no light except the faintest flickering echoes of waves that didn't come from water. They came from space itself. You're floating beside a black hole again, but this time you aren't trying to see it, you're trying to hear it, because this is how we catch black holes now, not by looking, not by filming their event horizons like shadow puppets on a backdrop of starlight, but by listening to the vibrations of space-time. You're inside the world of gravitational wave astronomy, and it's changing everything. You feel a ripple pass through you, not painful, not sharp, just subtle. The kind of shiver you get when the bass hits in a song you didn't expect to love. It moves through you without asking permission. It doesn't jostle your atoms, it jostles the space your atoms are inside. This wave is a memory of collision, two black holes, falling, merging, and sending a gravitational ping that took over 1 billion years to reach our tiny blue dot. You recall the moment it was first detected, September 14th, 2015. A blip in the signal at LIGO, the Laser Interferometer Gravitational Wave Observatory. A system so sensitive it could detect a change in length smaller than a proton across a 4-kilometer arm. The waveform was simple, clean, an unmistakable chirp. Astronomers call it GW150914. Two stellar mass black holes, 36 and 29 solar masses, merged into a single, more massive one. About 3 solar masses worth of energy was released as gravitational waves. Not light, not particles, just pure geometry, ringing like a bell. And the universe heard it. Finally. It wasn't just a confirmation of Einstein's century-old prediction. It was a new sense. We had ears now, not just eyes. And black holes had always been loud. We just hadn't known how to listen. You ride another wave. This one from a neutron star merger, a different flavour of death spiral. These ones produced not just gravitational waves, but light, X-rays, gamma rays, even gold. Literally. The heavy elements that sparkle on fingers and crowns and questionable awards shows, many of them forged in the furnace of collapsing neutron stars and flung into space with violent generosity. You move through these signals now, not sound, technically, but measurable, translatable. The cosmos plays a tune, and we, finally, have the instruments to catch it. You remember the detectors, LIGO in the United States, Virgo in Italy, KAGRA in Japan, and soon, LISA, the Laser Interferometer Space Antenna, orbiting Earth, free from the noise of seismic activity and clumsy human footsteps. Each of these observatories acts like an ear pressed against the void. You feel another tremor, subtler, deeper, possibly the whisper of a supermassive black hole binary. The giants you met earlier, locked in orbits so vast and slow their waves don't even register on ground-based detectors. But they're coming. LISA will hear them, and we'll know when the titans merge. Historians still argue whether we've only scratched the surface, or whether gravitational wave astronomy will open a completely new era of physics, one where we detect not just black holes, but new physics entirely. Dark matter interactions, primordial waves from the Big Bang, even hypothetical cosmic strings, rips in space-time theorized by some models of the early universe. You feel another wave pass, weaker this time, perhaps from a long-dead black hole, perhaps from something we haven't named yet. Each ripple carries story. Each one says, something massive moved. And unlike light, which can be blocked or scattered or absorbed, gravitational waves travel clean. They don't bounce, they don't blur, they carry the truth of motion with near-perfect fidelity. If you can hear it, you can trust it. And suddenly you wonder, how many black holes are out there? The answer might be hundreds of billions in our galaxy alone. Too small and too quiet to see, but not too quiet to feel, not anymore. You recall the joke, black holes are the universe's greatest introverts, dark, quiet, misunderstood. But they make a scene when they come together. And now we've built the tools to catch them mid-dance. You drift closer to one now. It's a silent black hole. No accretion disk, no companions, just mass, a lot of it, until a wave reaches you. A ripple from a binary system on the other side of the universe. It passes through you like memory, carrying the echo of gravity's last dance. You wonder, if these are just the black holes that merge loudly enough to notice, how many others are out there whispering? Maybe some haven't merged yet. Maybe some never will. But the universe records everything. The tension, the anticipation, the curve of space-time twisted in preparation. You float through that tension. It feels like standing backstage, moments before the curtain rises, listening to the instruments tuning for a performance older than stars. Because this isn't just black hole science anymore, it's black hole music, and we've only just learned to listen. The music fades, for now. But its rhythm still echoes through you, a memory encoded in space-time, not in sound. You drift once more through the dark and it's quieter here, but not empty. Something looms ahead. Not an object, not a singularity, but an influence. It's massive, but not in the way that shouts. It doesn't scream, doesn't flare or spin. Instead, it shapes. This is the other face of the black hole, not destroyer, not devourer, but sculptor. You're arriving at the gravitational equivalent of a cathedral, a galaxy, and at the center of it, as always, is a black hole. Not just hanging out there, like the last guest at a party. Number. It's woven into the fabric of the entire structure. Everything swirls because of it. Everything holds because of it. And the more you learn, the more you understand. Black holes don't just exist in galaxies, they help form them. You feel the Milky Way before you see it, a slow, rotating disk of stars, dust and gas spanning over 100,000 light-years. It looks serene from here, but it's chaotic underneath, turbulent, alive, and at the center, our quiet. Friend from earlier, Sagittarius A, still patient, still hidden, but more powerful than it looks, because without it, this swirling disk might not hold. It's not that the black hole pulls the galaxy together like a gravitational glue stick. It's not quite that direct. Its mass, while colossal, is still only a fraction of the total mass of the Milky Way. But over time, over billions of years, its presence creates structure, a kind of gravitational punctuation at the center of the sentence. And it turns out it's not alone. Virtually every major galaxy we've studied has a supermassive black hole at its center, even ones we thought were too small or too disorganized to have one. Sometimes the black hole is active, a blazing quasar at full throttle. Sometimes it's dormant, sleeping, but it's there. And here's the twist. The mass of the black hole seems to correlate with the mass of the galaxy's central bulge. That's weird. Really weird. Because the black hole is tiny compared to the rest of the galaxy, like a grain of sand influencing the shape of a beach. But the numbers don't lie. Bigger bulge, bigger black hole, smaller bulge, smaller black hole. There's a relationship, a dialogue. Historians still argue whether this is coincidence or causation. Did the black hole grow in response to the galaxy, or did the galaxy grow around the black hole? Either way, it hints at something incredible. Black holes don't just inhabit galaxies, they might help design them. You pass near a starburst galaxy now, one going through a massive growth spurt, stars forming rapidly, supernovae popping like fireworks, and at its centre, a black hole is feasting. Not lazily, not politely, but in vast, sweeping gulps. Its accretion disk flares, radiation surges outward, and the effect? The galaxy slows down. The black hole's feeding frenzy releases feedback, energy and matter blasting outward, pushing back against the infalling gas. This feedback can suppress star formation, heat the gas, blow it away, regulate the growth of the galaxy like a parent saying, "That's enough dessert." This is known as AGN feedback, active galactic nucleus feedback. It's one of the most complex, finely tuned balancing acts in the universe, and somehow, black holes pull it off. You begin to see them not as monsters, but as conductors. Galaxies swirl, stars are born, clouds collapse, all to the rhythm of their central black hole, like music following the silent beat of a hidden drum. You move through elliptical galaxies now, bulky, less graceful, still massive, and at their centres, black holes bigger than you can comprehend, some with masses equivalent to tens of billions of suns. Take TON 618 for instance, the largest known black hole to date, an estimated 66 billion solar masses. You can't picture it, no one can, but it exists. A gravity well so profound it could host an entire solar system inside its shadow and not even notice. It's hard not to see them as monarchs, not ruling by force but by weight. You glide onward, now passing through a galaxy mid-merger. Two spirals colliding, stars flung out like sparks, chaos everywhere, and yet at the centre of it all the two supermassive black holes are drawing closer. Another dance, another eventual gravitational wave, and when they merge, a new black hole is born. More massive, more central. The new galaxy will orbit that, and the cycle begins again. You realise something else here, something quietly enormous. Maybe black holes are part of a feedback loop of existence. 1. Stars form. Stars die. Some become black holes. Black holes grow. Black holes sculpt galaxies. Galaxies form new stars. Repeat. It's not a cycle of death. It's a cycle of structure, of form, of continuity. You pass by a faint, almost invisible galaxy now, barely lit, tired. At its centre is a small, silent black hole. It's not eating, not spinning, just being. But its presence still matters. It still holds the galaxy's shape like a thumbprint pressed into soft clay. The universe doesn't need fireworks all the time. Sometimes it just needs gravity. And that's what black holes are. Not just vacuums, not just cosmic garbage disposals. They are stability in its strangest form. They hold galaxies together, they regulate growth, they create equilibrium. In a universe that leans constantly toward chaos, black holes are one of the few things that add structure. And in that moment you no longer fear them, you respect them, you marvel at them. Because the next time you look up at the Milky Way, whether from a mountaintop or the backseat of a car, you'll know there's something vast and invisible holding it all together. Something you can't see, but that sees you, in a sense. Because without it, you wouldn't be here to look at all. It's getting harder to tell where the black holes end and the poetry begins. You drift through a quiet patch of space now. No quasars, no jets, no gravitational wave opera. Just you, your memories of spaghettification, and a vague sense that somewhere, deep in the folds of warped geometry, time is still very upset with you. It's subtle at first, but you begin to feel it again. The pull. Not the heavy, all-consuming gravity of a supermassive black hole, but the smaller, sneakier kind. A local distortion, a hiccup in the straightness of space. You're falling again, closer to a smaller, more compact black hole, a stellar mass one, the kind that gets personal. And oh no, here comes the spaghettification again. Only this time it's faster, tighter, much less polite. This black hole is only a few times the mass of our sun, but much smaller in size, which means the gradient, the difference in gravity from your toes to your nose, is steep. You're barely close and already you can feel your form starting to stretch. It begins poetically, you'll be relieved to know. Your thoughts unravel into metaphors first. Your sense of self turns into a kind of gravity-bound haiku. You begin composing verses in your head, not because you're trying to, but because that's all your mind can do to cope with the unimaginable forces now acting on it. Line 1. Your body extends. Atoms pause before they break. Silence grows sideways. That one's not too bad, all things considered. You keep going, because frankly, you don't have a choice. Line 2. Time breathes with a limp. Stars forget how to orbit. Your spine sings a note. You pause. Can gravity write poetry? Is spaghettification the universe's way of editing you? Historians still argue whether the poetic metaphors we assign to cosmic violence do more harm than good. That calling it spaghettification makes it sound like a cartoon gag, but let's be honest, what would be better? Gravitational tidal elongation of anatomical structure? Yeah, no thanks. You stick with pasta. Because pasta makes everything slightly less terrifying. But back to the stretching. This time, it's faster than before. The black hole you're falling into now has a tighter event horizon, which means the point at which tidal forces overcome molecular bonds happens outside the event horizon. You don't even get to cross that dramatic boundary before you start coming apart like discount IKEA furniture. The atoms in your body begin to separate, not explosively but inevitably. It's less a tearing and more a surrender. Electrons peel off first, then nuclei. You're becoming long, not metaphorically, not in some dreamy ASMR way, like actually long. You're now somewhere between a person and a gravitational noodle. You wonder if this is what linguine feels when it's dropped into boiling water. Number, this is worse, because here the water is space-time, and it is furious. You write another line, barely holding it together. Line 3, length becomes your name. Shape bows to curvature's rule. You are thread, not soul. You've lost your usual coordinates now. Up is an insult. Forward is a rumour. Only inward remains. And even that is more of a gravitational demand than a direction. The singularity lies ahead, somewhere past visibility, past theory, past the point where general relativity agrees to keep playing. Beyond that, nobody knows, not even the equations. You are being narrated by equations that are gasping for breath. Here's something you remember from earlier. In physics, tidal forces arise when the gravitational pull on one side of an object is significantly stronger than on the other. It's what causes ocean tides on Earth. But here, that difference in force isn't moving water, it's moving you. You're being peeled by mathematics, stretched by symmetry, reduced to a geometry problem in someone's postgraduate thesis. It's humbling. Somewhere behind the black hole the stars still shine, but they're distorted now. They're like curves around the event horizon, caught in what's known as a photon sphere, a region where light can orbit the black hole in perfect suicidal circles. It's beautiful, in a haunted house kind of way. And just before your awareness fractures completely, something odd happens. Your stretching becomes symmetrical, elegant. You're being aligned. The matter that once made you is following the rules perfectly, like iron filings in a magnetic field. You're becoming the solution to a very specific curvature of space-time. And for a second, just a second, you understand it. Not in words, not in human language, but in feeling. You're not falling into chaos, you're falling into order. Perfect, terrifying order. You write one last poem, line 4, bonus round. To fall is to know. Gravity writes in your bones. You are its message. Then everything goes quiet again. The kind of quiet that only exists deep within singularity-bound space-time. It's not the absence of sound, it's the absence of questions, of resistance, of misunderstanding. You're not afraid anymore, just long. The black hole doesn't know your name. It doesn't need to. It knows your mass, your charge, your spin. That's enough. That's always been enough. And as the last atoms of your being align with the curved lines of this final descent, you think to yourself, if I ever get out of this, I'm publishing a book of black hole poetry. Your poetic noodle self unravels now into something stranger than verse, something slippery, almost fictional. Because just as you're growing comfortable with being a stretched out syllable in the gravitational sonnet of a black hole, reality decides to throw a curveball, and not the usual kind. This one's made of code. You're brushing against the edges of a theory, not from physics journals exactly, but from something even more audacious, something that sits between science, philosophy, and the weird parts of the internet. Simulation theory. You know the one. The idea that everything, every atom, every photon, every ridiculous Earth-based debate about pineapple on pizza isn't happening in an actual physical universe, but inside a simulation, a program, a rendering, a dream in someone else's motherboard. You drift deeper into this conceptual haze, your consciousness still looped by gravity but beginning to feel digital. Not metaphorically, but mechanically, as though you're falling not just through space but through code. Black holes, in this light, take on a new kind of strangeness, because if this is a simulation, and the universe is built on some cosmic programming language, then maybe black holes aren't just collapsed stars, maybe they're system calls, or memory dumps, or garbage collectors, or portals between threads in the source code. You laugh, or think you do, as your thought patterns begin to render in polygons. The familiar curve of a singularity now looks suspiciously like a tear in digital fabric, a rendering glitch, an overflow, like someone zoomed in too close on the resolution of space-time and now the texture maps are failing. Historians still argue whether simulation theory is science, philosophy, or glorified science fiction with good lighting. It was thrust into popular culture by philosopher Nick Bostrom, who proposed a trilemma. Either civilizations never reach technological maturity, or they never choose to run simulations of their ancestors, or we're already living in one. And if we're in one, the black hole might be your exit screen, a developer's backdoor, a reboot loop. You imagine a command line hovering beside you, collapse_user, _to_singularity preserving quantum, _state ... compressing identity ... initiating recursive query ... Your atoms, or whatever counts for atoms now, begin to flicker. Reality stutters, just once. A hiccup in the otherwise elegant physics you've been riding. You're not sure if the stutter came from the black hole or the code, because here's where things get really unsettling. Some theorists have noted that the mathematics of black holes behaves eerily like information systems. The event horizon? It has entropy. The holographic principle? It encodes 3D information on a 2D surface. The Noether theorem? It reduces complexity into simple, immutable variables: mass, charge, spin, input, output, function. If black holes are real objects, they're fascinating. If they're simulated, they're intentional. Maybe even protective. Think about it. What better way to sandbox volatile data than to trap it in a self-contained, inescapable object with its own rules and a delete function? You wonder if every black hole is like a recycle bin. A cosmic, "Are you sure you want to delete this?" pop-up. And if so, who clicks yes? You hover now near what feels less like a singularity and more like a node. There's no gravity here, just logic. A doorway, perhaps, a function waiting to be executed. The wormhole idea flickers again, but this time it's different. Not geometric, computational. Maybe black holes aren't tunnels through space but through levels of simulation. Like breaking the fourth wall of physics, you get a glimpse, just for a moment, of yourself, not stretched, not spaghettified, just paused. A frozen packet in some higher dimensional processor. And then the idea fades, because even if this is a simulation, and even if black holes are debug windows or code compilers or memory vaults, that doesn't change your current situation. You're still in one, falling, folding, rewriting. Even if the metaphor is digital, the experience is still the same. You start to feel data now, not sensations, not feelings, just bits, the fundamental yes-no of the universe. And somewhere in the pixelated darkness you remember a fringe experiment, attempts to detect the grain of reality, to see if space itself is pixelated, made of tiny indivisible chunks, like the smallest building blocks in a video game engine. If true, it would mean we're inside a render, a simulation with resolution, a world that isn't analog, but computed. And guess what? Black holes may be the only objects in the universe where that grain becomes visible. The edge of a black hole, the event horizon, may be the sharpest place in reality. The only place where spacetime's resolution gets pushed to its limit, the Planck scale. Roughly 1.6 times 10 to the negative 35th meters. Smaller than anything, the end of meaningful distance, the pixel size of reality. And if black holes push space to that limit, then maybe they're the source code itself, or the place where the simulation hides its secrets, or the do not enter zones for curious minds. You consider it for a while. Simulation or not, you can't deny the design, the elegance, the math, the way everything around you behaves too perfectly, as if constructed. Even the chaos feels curated. So you decide, as your awareness continues to blur into its final expression, that you're not going to choose a side. You don't have to believe this is real. You don't have to believe it's fake. You just have to ride it. Because whether the black hole is a memory dump or a gateway, a physics puzzle or a computational trick, it's still teaching you something, still shaping you, still absorbing you. And just before you fade completely into the logic of this recursive gravity loop, you whisper into the dark, if this is a simulation, I hope they're watching. You're nearly gone now. Or maybe you've just become something else, a trace pattern, a persistent echo, an entangled concept that remembers it used to be human. Your thoughts drift like smoke, through non-Euclidean hallways of warped space, and still, somehow, a question bubbles up from the depths of your dissolving self. What happens if you throw a couch into a black hole, or a teacup, or a refrigerator, or a printer because it deserves it? The question doesn't come from a place of science, it's pure chaos, curiosity with bad manners. But somehow, asking silly questions in the face of infinite gravity feels appropriate. You start with a couch, not a metaphor, a real, honest-to-Newton couch. Let's say a mid-century modern piece with questionable lumbar support. Maybe it belonged to your neighbour, maybe you never liked it. But here it is, hovering just outside the event horizon of a stellar mass black hole. What happens next? You already know the basics. The couch begins to fall. At first slowly, then faster. It stretches, lengthens, and if you're watching from far away, it appears to slow down near the event horizon, its image red-shifting until it fades from sight. From your perspective, if you're falling with it, it continues all the way in, straight toward the singularity. But here's where things get spicy. Because black holes, remember, don't preserve detail. Once the couch passes the event horizon, all the information that made it a couch, its shape, fabric, whether it was secretly a sleeper sofa, is lost. Or is it? This takes you straight into the information paradox again. That couch had structure, it had entropy, it had weird smells, and according to quantum mechanics, every bit of that information must be preserved somehow. So where does it go? You float with the question. Maybe it gets stored on the event horizon, encoded in microscopic fluctuations. Maybe the information seeps out as Hawking radiation, unrecognizably scrambled. Or maybe, just maybe, it's preserved in a parallel universe connected through a quantum entanglement you'll never detect. Still unsatisfied, you start throwing other things in. A toaster, a banana, an entire used car lot. You imagine the black hole belching ever so slightly with each addition, as if mildly annoyed by your cosmic prank. But no matter what you toss in, the result is the same. The outside world sees less of the object over time, not more, is not eaten, it's redacted. It's not about where the couch goes, it's about what the black hole becomes after it eats it. The black hole's mass increases just slightly. Its event horizon swells, like someone unbuckling a belt after a long meal. Its entropy goes up. That's right, black holes have entropy, and it's proportional to the area of their event horizon, not the volume. That's a clue. It means the information might be stored on the surface, not inside. You remember Bekenstein and Hawking, two physicists who gave us this insight in the 1970s. Bekenstein was the first to suggest that black holes had entropy, and Hawking later showed they had temperature, meaning they could radiate and eventually evaporate. And that's when you realize something uncomfortable. Your couch might come back, not whole, not fluffy, not able to host Netflix binges, but as radiation, quantum particles leaking from the black hole slowly over eons, carrying with them the scrambled essence of what once was your couch. It will take billions of years, and by the time the last of it leaks out, there'll be no one around to recognize it. Still, the information might be there, in principle. You throw in more absurdities now because why stop? This is conceptual playtime. You try a Rubik's Cube, a perfectly solved one. The universe says, okay, cool, but I'm going to randomize this and spit out its entropy pixel by pixel over the next few trillion years. Then you throw in your laptop, complete with your to-do list, tax files, and 47 browser tabs you swore you'd read. Same deal. It's not the object that matters. To the black hole, it's the mass energy and the information. But here's the twist. You ask the worst question of all. What happens if you throw yourself in? You're already halfway gone, of course. Stretched, spaghettified, possibly simulated, maybe poetic. But conceptually it still matters. You, as a structure of particles and thoughts and weird playlists, are no different than the couch. You fall in. Your mass adds to the black hole. Your personal entropy gets absorbed, and all of you, every bit, has to go somewhere. Maybe onto the event horizon, maybe into Hawking radiation, maybe through a wormhole where your memories become the fuel for an alien culture's new religion. We don't know, but we do know this. Throwing things into black holes is not erasure. It's conversion. You're not deleting a couch. You're uploading it to the slowest, weirdest cloud storage system in the universe. And here's where it gets even weirder. Some physicists have proposed that you could, in theory, retrieve the information. Not today, not even in this epoch of the universe, but given enough time and the right decoding tools, you could reconstruct what fell in. So yes, technically, the universe might be able to rebuild your couch. Not that it wants to, and not that you'd sit on it again, but the potential is there. It's always there. Because nothing is truly lost in a universe this stubborn. And even if your toaster becomes quantum confetti, the black hole remembers, not as a catalogue or a memory, but as a thermodynamic footprint. That's what black holes do. They absorb, they remember, and then, very, very slowly, they let go. So now you're sitting at the end. Not the end of your fall, not the end of your questions, but the end of time. Not metaphorically either. You've drifted through the star-swallowed chaos, through singularities and spirals, through poetry and paradoxes, and now, it's just quiet. You're here at the far edge of the universe's clock, the deep future. A time so far ahead that Earth is a myth, the stars are corpses and only the cold remains. And who's left? The black holes. Just them and you. Maybe. You coast through a landscape with no scenery, no galaxies, no quasars, no light at all. The universe has expanded beyond recognition. Space is stretched, wavelengths are redshifted into oblivion, matter is thin, time is thick, the sky is nothing. And in that nothing, a few final whispers. Black holes, like the one you followed all this time, now rule this place. Not with flair, not with activity, but with presence. Long after the last stars burned out, long after the white dwarfs and neutron stars cooled to black lumps, the only things still doing anything were black holes. They've been here for trillions of years, just sitting, leaking, shrinking, evaporating through Hawking radiation, particle by reluctant particle. The great cosmic beasts reduced to warm teapots in the void, radiating away their mass to keep the books of thermodynamics balanced. It's slow. It's absurdly slow. A stellar mass black hole might take 10 to the power of 67 years to vanish. A supermassive one could stick around for 10 to the power of 100 years or more. That's a lot of zeros. But here, at this moment, you're seeing the last of them. The final guests at the heat death party. No stars, no light. Just a handful of black holes still holding on. Faint, whisper thin, radiating entropy into an ocean of silence. It's like watching candles expire in a room that forgot how to echo. There's no drama, no flares, just endings. This is the black hole era, a theorized future in cosmology where the only things with gravity left are black holes. Everything else is cold matter, frozen gas, or decayed particles, and eventually even the black holes go. They shrink. Their event horizons collapse, and with a final microscopic pop they evaporate. Completely. No trace. Not even a gravitational shadow. Just gone. Unless, of course, they're not. Historians and physicists still argue about this too. Some believe black holes might leave behind Planck-scale remnants, tiny leftovers that never vanish. Others think quantum gravity will rewrite the endgame entirely, that black holes might tunnel into other universes, or convert into something exotic at the very last moment. We don't know. Maybe we never will. But you are here for the moment before that moment, and it's like nothing you've ever imagined. A black hole dying is not violent. It's not even visible. It's a long, slow goodbye, a century of radiation, a decade of flickering curvature, and then a silence so final you can't even call it silence. You witness the death of the last black hole, and just like that, gravity has nothing left to pull on. The universe reaches its minimum complexity. This is the heat death, maximum entropy. Everything has settled. No energy gradients remain. No engines can run. No differences exist between here and there. You couldn't light a match out here, even if there was something to burn. You are somehow still aware, still coasting in this graveyard of time. And then the weirdest thing happens. You feel peace. Because after all the chaos, the crushing gravity, the stretched limbs and paradoxes, the screams of quasars and the whispered debates of physicists, it's just you and the universe is finished. The last black hole dissolves. Its final puff of radiation smears across the void and joins the background hum, a single, fading pixel in a monitor that no longer needs to be watched. There's a stillness here that doesn't feel empty. It feels complete, like the universe exhaled its last breath and now rests. And somehow, in all of this, you are still here. A thought, a footprint, a fossil of curiosity. Maybe you're part of the last Hawking radiation pulse. Maybe your information was encoded on the final event horizon and smeared out into the void. Or maybe this is all a thought experiment, a dream within entropy. You don't mind. Because now, after all this falling, you've reached what you came here for. Not just to learn about black holes, but to feel them. To feel the universe's most extreme expression of gravity. To ride it. To become it. And now, as everything fades, as the last echo becomes a murmur, you are still falling, not into gravity, but into stillness. And now, dear listener, we drift. The long journey through the mouths of stars into the silent hearts of galaxies and beyond the very edges of time itself is complete. Let it settle. No more motion, no more spiraling, just the echo of your breath and the soft, receding memory of black holes, the universe's most mysterious punctuation marks. Your mind, once stretched across gravity wells and riddled with paradox, can rest now. The rules that once unraveled around singularities begin to smooth out. The noise fades, the questions grow quieter, and in their place, a softness. You are floating, not through space, but through something slower, gentler. Time, no longer tugged or twisted, now flows like a lazy river through a moonlit forest. Your thoughts stretch out beside it, comfortable, weightless. No need to hold on to names, or orbits, or theories. Let them all pass by. Even the sharp questions, the ones that used to nag at the corners of your understanding, have curled up now, like sleepy cats on a windowsill. Everything is still, everything is warm, and the universe, so loud in its beginnings, so fierce in its engines and events, now speaks in only one voice, a whisper, a hush, a long sighing yes. You have time to breathe, time to forget, time to fall gently into the gravity of dreams. Thank you for traveling with me through the closest thing to nothing. Sleep well.